The next speaker is Simon Field from Microsoft, and the topic is working R on Spark with Microsoft Azure. So please welcome Simon.
Oh, okay, it'll be fine. I might need some power as well. Okay, great. Thanks, everybody. So my name's Simon Field. I work at Microsoft. I've been at Microsoft a little over 3 years and joined through the Revolution Analytics acquisition. So if some of you are probably familiar with Revolution Analytics, a company that was focused around helping customers adopt and embrace R in the enterprise. And given I've been at Microsoft 3 years, I guess they must be doing something right. I'm still here, right? What I'd like to talk to you about today is how you can use Spark on our cloud platform and some of the different options there and when to choose which option depending on the kind of processing you're doing. So first of all, what is Spark? I'm guessing that because I'm talking to a room full of data scientists that you've probably would have looked something like this if you don't know anything about Spark. You'd have had to have your head in the sand. The other way of looking at this is actually, from my experience, when you actually try and build and construct Spark clusters or Spark processing environments, it can get very, very complex and difficult to maintain and manage. And you might feel like this after you've been trying to battle with that processing and configuration for a while. And again, Azure can help significantly in making it very easy to get started using Spark. I'll show that in a bit. I guess the other thing is that none of these guys are looking at the cloud, right? So the cloud is a great option for running Spark, and we'll get into the details of that as we go on. So what are some of the common patterns and use cases for using Spark? So the technology was kind of designed for handling big data processing. So maybe if I can get everybody to put their hand up. So, and then take your hand down if you're regularly processing data that's about 1 gigabyte or less. Okay. Or take your hand, actually, so most people are dealing with data sets under 1 gigabyte, is that right? Okay. So Spark may not be the right processing technology for you, okay, if you're dealing with small data sets. However, there are some advantages to even using Spark if you have got small data sets in terms of scaling the processing for embarrassingly parallel type workloads. So if you're doing simulations, forecasting, where you need to run lots and lots of models or lots and lots of things in parallel, then that's a great application of Spark as well. In addition, there are a number of machine learning libraries in Spark, some that run native on the platform, developed by the Spark Apache community, and others from other providers such as Microsoft and H2O. There's been talks this week about some of those technologies and how they work. And all of those can be applied to Spark on Azure because it is just Spark at the end of the day. You can also use, maybe people not so familiar with this, but you can also use Spark to process streaming data, real-time data, or at least very close to real-time data. So there's been a lot of enhancements and development in the platform to support that kind of engine. So working with very tight windows of data as data's flowing from devices messaging, those kind of things. So a very kind of efficient way of processing real-time data if you need to get a decision point very close to the data actually being generated. So the way that works, or the way that kind of Spark looks, is you have a core engine, which has a number of different processing primitives. And then on top of that core engine, a number of different APIs or languages are supported. So there's a SQL kind of processing engine for running queries, joining data, aggregating data. There's the machine learning libraries I talked of earlier. So a limited subset, but nevertheless a number of modeling functions for doing supervised and unsupervised learning. There's the Spark Streaming API, which also now supports SQL. So you can define time windows in a SQL statement and understand data or ingest data as it's flowing through using that time window. And in addition, there's a graph processing API as well. So if you're trying to process graph type data or network data, and there's an optimal API for processing that kind of data. So what are the Spark options on Azure then? So first of all, you can run Spark on a single machine. You can run it on your laptop. And you might get some benefit from that if you've got multiple cores on your laptop. So you maybe get some processing efficiency from parallelization. But what about if you haven't got a large enough laptop? Well, we can provide that kind of facility in the cloud, and I'll get into the details of that in a minute, through something called the Data Science VM, or virtual machine. We have a couple of three large-scale solutions for scaling out beyond a single machine. So if you need more than one machine, because the processing needs are greater than you can process in time on a single machine, then we have something called Azure Databricks, a kind of very prescriptive service that makes it very easy to get going with Spark. We have HD Insight, which is our Hadoop service in the cloud. That's really good if you're trying to integrate other types of Hadoop processing framework alongside Spark. And then we have Azure Batch, which provides a really nice environment if you're doing deep learning type training, and particularly if you need access to GPUs and you need to drive a lot of processing at a very efficient cost point. But first of all, just a kind of quick segue into the kind of package ecosystem of Spark on R. So there are a lot of packages out there, and I suspect this list is by no means comprehensive. There is the Spark R package from the Apache Spark community itself. RStudio have done a great job of building out some packages to integrate with the dplyr and some of the other tools that you'll be familiar with from RStudio, so that those integrate and work well in Spark, processing and using Spark as the processing engine. H2O, I mentioned earlier, again, have some machine learning functions that integrate and work well in Spark with an R-based API. And then at Microsoft, we've also developed some machine learning functions and some data processing functions for handling large-scale data over Spark. So there's a number of different options here, and you can use all of these. And one of the nice things about kind of working in Spark with these packages is that the objects that you create in memory Spark data frames can be used as an interchange format for data between these different packages. So you can write a single script that uses functions across all of these packages. So, as I mentioned, have you ever needed a more powerful laptop? Or have you ever just got fed up with carrying around these massive machines just because you need to do some data science on your laptop? And one of the really nice things about Azure is this kind of ability to scale processing on a single machine. But every time you come to Microsoft Cloud, You don't want to go and build and construct a machine and install R and install Python and install RStudio and all of the other tools that you might need as part of the piece of work that you're doing. So we provide a pre-built, pre-installed machine that you can use and start. Choose the size of machine that you want to spin up, and then connect and work with that. And we even provide some nice tools and packages in R to make it easy to start up those machines programmatically from R, which I'll show you in a minute. There are 3 flavors of the virtual machine, depending on what operating system you like to work with. So there's a Windows-based version. There are 2 Linux flavors, CentOS and Ubuntu. And there's also GPU capability here as well, so you can hook up GPU-based instances if you need to do, again, deep learning processing or something that needs that greater scale of processing, such as deep learning. So I probably can't see this from the back of the room, but just an example here of just one of the types of instance and different scale units that are available within that virtual instance in Azure. So it scales from 2 CPU through to 64 CPU, up to 432 gigabytes. Quite a lot of temporary storage space, nearly a terabyte of storage space for working with data. And it's going to cost you at 64 CPUs about $6 an hour at list price. So not particularly expensive if you need that kind of compute power. There are multiple different ways. There's a portal that you can go into and configure and set these things up, drag and drop or click through. But if you don't want to do that and you don't want to learn PowerShell or CLI commands for Azure, then we've created a package to make it easy for you to do this with R. So here you can see an example, again, maybe a little bit difficult to see with the text size, but using this package, Azure SMR, you can configure the size of machine you want, give it a few extra parameters, kick this process off, and it will start a data science virtual machine for you in the background. If you've created this once before, then you can go in and you've got that image kind of pre-created. You can go in and restart it and stop it as and when needed, all from R, so you can build some scripts around this. Might be useful if you've got some heavy lift processing that you want to do, that you can defer to the cloud, and you can build an R script that scheduled and run and starts up the processing for you. And you can connect to it programmatically as well, using a number of different options. So because the data science VM has Jupyter and RStudio and other tools on it, you can connect to it through a browser quite easily as well, once you've started it. And obviously once you're done and no longer need the machine, you can just shut it down and you're no longer going to get charged for the cost. The cost is per minute. So even though the hourly rate I gave you earlier is like $6 an hour, you'll only get charged pro rata per minute for what you're using. So a good idea to shut it down when you're not using it. Okay, so what about Azure Databricks then? So Azure Databricks is a relatively new service on Azure. It provides a Spark ecosystem that's really easy to use. I'll show you a few screen captures in a minute of what that environment looks like. It's really good as a collaborative workspace for multiple users. So whereas the data science VM is good maybe just for a single user, I mean, you could connect multiple users to it, depending on the size of machine. But this is good as an environment for multiple data scientists, data engineers to work together collaboratively on data sets. You can, within the workspace, define and create clusters for a certain time window, or it's even got a serverless computing model where you just define the maximum number of servers or cores that you want to process over, and it will work out elastically for the particular job that you're running, how many cores are needed to run that efficiently. It allows you to put pipelines of processing together. All the development work is done within a notebook-style environment, very similar to Jupyter Notebooks. There's a tasks scheduler in there as well, so you can schedule processing to run at specific points in time. And all of these facilities are also triggerable from outside Databricks using some of our other scheduling services in Azure. So if you've got a longer data processing pipeline where Databricks is part of that, you can schedule that to run based on files landing or data sets arriving in certain places, etc. And you can link it up to a number of the other data services that we have in Azure, so scalable database technologies, our messaging services for queuing and event-based processing, and unstructured data sources as well. So, yeah, again, difficult to see with the resolution on the monitor here. So, a few screen caps. So you go in, you define a cluster size that you want, or the serverless pool, if you just want a pool of cores that you want to work over. And then you develop and create notebooks and write your code in notebooks. And then to run the notebook and step through the notebook, you can attach it to a cluster. So you could actually have several clusters all within the same workspace, the same kind of area that multiple users are sharing, maybe one for development that's a certain rev level in terms of software, and then another cluster that's at a different revision level for production, all within the same area that people are working on collaboratively. And as I said, it's a notebook-style development environment, so you can put in Markdown, R code, execute that, and it also provides some basic plotting and charting, dynamic charting capability for the tabular data that you bring back. So that's quite nice if you're just doing some exploratory analysis and you don't want to have to keep writing ggplot or plotting functions over the data that you're looking at. Just to quickly get a view of the data. And again, machine learning type capability as well, so it supports all of those packages that I mentioned earlier for machine learning. So the Databricks service is pretty new. It's been around about 6 months, but it's the fastest growing service in Azure, data service in Azure, which I think talks to the popularity of Spark and how easy this is to use. And the nice thing about this service is it's very, very tightly coupled. We've worked very, very closely with Databricks, the kind of founders of the Spark technology, to integrate this very, very tightly into the other data and processing services in Azure. So there are a couple of other options I just want to cover briefly. So if you are using a number of different open source big data processing technologies from the Hadoop ecosystem, so maybe things like Kafka or Storm for stream-based processing, Hive if you're doing query processing, then HD Insight enables you to run all of those services on a cluster, so kind of like a shared environment, as well as Spark. So typically customers will use this when they want to create a permanent cluster that's persisted and going to be just left running, maybe scales up and down a little bit in terms of compute, but ultimately is going to sit there and be processing a number of batch or stream-based processing things over time. And you don't want to keep on taking down or bringing up the cluster. And then the other option is really if you're doing, I think this is more suited to deep learning. So if you need to train any of the deep learning frameworks, and particularly if you want to get access to some of the fastest GPUs that we have in Azure, then this is a great environment for doing scalable deep learning across single or multiple machines. Very typically, it's so you can scale out to multiple machines to do that deep learning as a batch type process. So just to kind of wrap up in terms of comparison of these different services and when you might use one versus the other. So the data science VM is ideal if you just want to rock up as a single user and you need something with a bit more horsepower than you've got in your laptop. Or you want to leave something running because you've got some processing to run and you need to shut down your laptop and run out the door. It's that kind of persisted environment that's running for you. It's good for interactive and scheduling, obviously. It's very low cost, kind of just bare bones paying for the virtual machine cores itself rather than anything else. There's no software charge. And you can access GPUs through this as well, so if you need to do deep learning on a single machine, it's good for that. For everything else, pretty much, I would use Databricks, unless there's a very specific reason why you don't need Databricks in terms of scale. The other two services I mentioned are okay, and service particular, very specific needs, but the Databricks service is probably the other service you go to if you need to scale out beyond a single machine. And if you want to get started, we do provide free account with a certain amount of dollar value to it. So you can register and get access and start playing around with this technology very accessibly for a few months before you use up that credit, and obviously then would have to provide your own. Okay, so thanks very much, everybody. I'll be around, obviously, for the remainder of the day if you do want to catch up with me and ask any specific questions. Thank you.
Thank you very much for the presentation.